approach as we transition into our discussion here on WebAssembly. So I'd love to welcome our speakers. I'll start over there. Chris Matteson, Fermyon, Head of Solution Sales. You want to say a couple words about yourself, your background, and what you do at Fermyon?
Yeah, definitely. As I just mentioned, I was an early employee at HashiCorp. Before that, I was Puppet. Before that, I did a bunch of resale consulting. I've kind of been doing this like IT consulting, DevOps stuff for a long time, and then love solutions engineering. And I made the mistake of going into management, and then trying to like be the salesperson myself. But I do love it, and I think I've been here a year. There's three things that I've been really excited about trend wise, which are serverless, WebAssembly, and AI. So I joined a serverless WebAssembly company, and then I passed through the CTO and just created an AI service. So now I'm in my happy place.
All right. Bailey Hayes, Chief Technology Officer at Cosmonic.
Yeah, CTO at Cosmonic. I wasn't always the CTO. But I feel like I'm always a little bit weird when I get that title, honestly. I still think of myself as an engineer. I'm the WASI co-chair. WASI is part of basically the standards body for WebAssembly. There's the WebAssembly community group, that's part of the W3C. And then there's this working group where we're working on growing the standards so that we can run WebAssembly basically everywhere in the web, in a browser, or on the server side. And I'm also a technical steering committee director on the Bytecode Alliance. So the Bytecode Alliance is a nonprofit for building out software foundations. Before I worked at Cosmonic, I was a platform engineer working on Kubernetes. And that's part of the reason why I'm really excited about WebAssembly components, and we'll dig into that more.
Ooh, WebAssembly components. Yeah, I heard a little bit about this earlier today. I'm excited. Oscar Spencer, F5, Principal Software Engineer.
Absolutely. I'm a principal engineer here at F5 on the NGINX team, in case y'all think NGINX is cooler. Besides that, my fame in the WebAssembly community is I am one of the co-authors of a programming language called Grain, which is a WebAssembly only programming language, which is pretty fun and happy to chat about it if people are interested. Beyond that, I just love WebAssembly, love using it. Before working at F5, I worked at a startup called Suborbital, where we built an entire product based on WebAssembly, and it was freaking awesome. And we were acquired by F5, which is why I'm here now.
Okay. The conversation is going to go pretty top down. Let's first a quick survey of the room. How many folks are using WebAssembly or have deployments currently? You can show of hands. The Cosmonic guys are cheating. All right, and odds Ed and Jimmy. With that, let's do an intro, right? Like, what, and why should I be looking at WebAssembly? What is it? What problems am I looking to solve? And I'll start here with you, Oscar.
Yeah, so WebAssembly just generally is it's a compiler target. It's a brand new compiler target that compilers different programming languages, whatever language you want, can compile down to WebAssembly. What's neat about WebAssembly is it runs in a sandboxed environment. So traditionally, when you have different like if you think about containers or something like that, they're a great way to keep code from leaking out and affecting other things running on the same system. However, it's not necessarily the most secure way to do it. There's a lot of ways containers can actually break out, and it's actually a little bit scary. But with WebAssembly, we say, hey, we actually know that this code is never going to affect other code that is running alongside it, which is super neat. On top of that, it's super duper fast. And not only that, it's also portable, meaning instead of worrying about, oh, is this going to run on x86? Is this going to run on ARM? It runs absolutely everywhere. It can run in your browser, it can run on your computer, it can run on your smartwatch, it can run on a light bulb. It doesn't care. It's going to run anywhere, which is super duper sweet.
The light bulb.
I love that. Okay. Also, massively multi-tenant, incredibly tiny, allows for streaming compilation, which I think is just like a crazy cool thing. A lot of people don't talk about that part because it's not as important as the other ones that Oscar just said so eloquently, but you would notice it, or wouldn't notice it, because it runs off of the main thread when you use it inside the web. And it does streaming compilation because of the nature of how it is basically a stack machine. And so being able to do that means by the time it's downloaded, it's able to instantly start. So WebAssembly can start in microseconds. Go ahead to you, Chris. There's so many more.
I mean, you guys took all the good stuff, but The analogy I really like is there was a promise that Java had a long time ago of being that one you write it once, you use it anywhere, right? And Java came along with lots of other Java things, and we've all either played around it or had the horror of taking a Java course, some CS degree. And WebAssembly, as they've said, is so much faster, so much elegant, so much more efficient, really because it was originally written for a very specific use case, which is to run in like the browser in a completely untrusted, because I don't trust anything that's downloading, right? It had to be super small to be fast, right? And we didn't want, and we wanted to be able to support other languages because JavaScript, which kind of was becoming the thing as Flash went away, and like Java really wasn't going to be a thing for the browser. Like we need something more efficient. Like how can I get my more efficient like C code in there, right? And then have it in a way that would be trusted. That's really like where it started, and that's a reason it has all these great features that we've suddenly found are useful elsewhere. Which we're like the Bytecode Alliance, right? We're all part of. Was about how do we take that WebAssembly off those designs for the front end and bring it to the back end and build all these standards so it can do all of these things beyond just the browser. And I think that's where all of the exciting stuff that like what's got all of us here really energized is like that WASI, the Bytecode Alliance, the back end stuff that we've been building now.
And piggybacking off of that, if you've ever used, and it's kind of new, but if you've ever used Photoshop in the browser, this was made possible by WebAssembly. So they have the huge C code base, right? And they were like, yeah, we want to run it in the browser, but it's C code, whatever. They compiled it down to WebAssembly, which ends up being like an 80 megabyte WebAssembly file. Which what's funny about that is WebAssembly modules are tiny. So for us, we're like 80 megabytes, like that's huge, right? And that sounds crazy, but running in the browser, thanks to streaming compilation, as soon as your computer makes a connection to the server and starts receiving bytes, it's already compiling that WebAssembly to be ready to run. So it actually loads pretty fast in the browser, and it's a pretty neat experience. So you probably are already using WebAssembly and don't even realize it.
I would say everybody in this room probably used WebAssembly today. Let's talk about who used Google Meet, Prime Video, Zoom. Like, just about this use case is everywhere. We don't often talk about it because when was the last time we talked about a .exe or a .so or some other underlying technology in your stack? Like, it's a little weird that we're so pumped about it, but also it is kind of incredible because we can do so many amazing things with it.
Yeah, it's super weird because since it's just a compiler target, sometimes I'm like, man, if I ever was like, oh man, I just love me some x86, like that'd be kind of weird, right? But that essentially is what we're doing.
I think this is the right room for that.
Yeah.
That's that much different than like when Docker was like, let's take this idea that's been sitting around Unix for a long time and make it a useful function,
Hmm.
right? And like now it's containers everything, including this like meeting today.
Yeah.
Yeah, I remember my first experience coming into contact. I was using the Twilio platform for serverless, and I'm like, I barely touch this from time to time, and I know that container warm up time for is like that's super responsive. How are they managing this? And voila, it's WebAssembly on the back end. Um, so let's talk a little bit about the ecosystem. There's standards, right? Some of these things I've come to learn are governed by the W3C. Can you talk a little bit about the standards around the technology, and maybe talk a little bit about what a stack looks like if I'm looking to deploy WebAssembly on my systems?
I want to hear you describe the stack part.
The stack part. Well, we want to do the standards stuff first.
Okay, standards are slow. That's the first thing you should know about standards. But if we're being real about it, we have awesome announcement to make on Thursday this week. We have now officially completed our second reference implementation of this next iteration of the standards. We call it WASI Preview 2. I like to call it .2 because I'm cool. But it is the next thing that we've been working on for the past like 3 years, maybe even longer. Might be getting into 4 years at this point. But I'm gonna stick with 3 years because I've been saying that for about 3 years. Is the ability to be able to have modular interfaces, be able to compose across different languages. So I can basically take a WebAssembly module that was written in Go, a WebAssembly module that was written in Rust. I don't have to write any of that, those bindings. And I can also do this with any other language. Those are just two examples. and seamlessly compose them together so that they communicate to each other in the same process because of WebAssembly isolation. That each part of WebAssembly has a linear memory for each one of those different components that I compose together. And we've added a ton of new features to the WASI spec, which are basically like new function definitions that we made available. But they have cool stuff that we did not have before, including sockets, HTTP, things that you might be like, oh, you didn't have that before, but
Don't worry about it.
don't worry about that. It's got it now, and it's going to be here on Thursday. I think that part's pretty exciting. We've been working across. I rattled off maybe 40 names, I think, in the WASI meeting right before the holidays, giving a thanks to everybody who contributed to the standard. 40 people is pretty awesome because it's across so many different organizations, and trying to get people who have potentially competing interests working together to come together and agree on building a thing that's going to be that fundamental unit of compute that now is the thing that we distribute everywhere around the world. It's pretty cool. It's pretty hard, but we did it.
Yeah.
I'm super excited about this. Phil just told me about the Necolic .2 thing on Monday, and now I'm like, I just tapped preview 2, so written in my brain.
I know.
Like preview 2, preview 2, preview 2. But no, I'm super excited about all of these things that are coming out. Like we're making phenomenal progress with building these standards, which allow companies like the three of ours to go actually implement that in a way that I think is really going to support the community. Right, like the purpose of the standards is not for any one of these companies here. It's so that like the larger ecosystem can take advantage of these tools, and whatever happens to like one of us, right? Like you've built something towards those standards. We've built things towards those standards. You're not going to be out in the lone wilderness because somehow one of these companies went away. Like you're building towards that thing that's going to continue to get broader adoption. We're going to see adoption across all of the the cloud providers, across more of these companies that want to go build WebAssembly into those tools. Doing it this way saves them the time of going and re-architecting a new way and building a new tool. Like that's for the community. And sockets, by the way, is one of the things I'm most jazzed about. I think that's going to make a huge difference in the developer experience of what you can actually go do versus what you're used to doing in the past. And then the components that you mentioned, I think, there's step one is just yes, I could write this in one thing and I can get access to another. I think step two and step three of components is going to change how people build software, which is why, and I've heard multiple people say this, that like the future of software will be composing WebAssembly components together because it'll be that much easier to just be like, let me take this off the shelf, super efficient authentication module, and let me auto generate a module based on the API of some service over here and have that and tie that together. And then, in a future world where we can tie security around the components and where data moves inside of that, right? Like the component model is enabling a way that's going to change how we build applications. Like it's not just I can go use a C library now instead of a JavaScript library with my JavaScript app. It's you won't build applications the same way in 3 years.
Yeah, so let's imagine for a moment that you're just some guy. You made a programming language, and a lot of people are like, "Yeah, that's like a cool project. Like that's cute." But like, you can't actually do too much because you don't have the full ecosystem yet, right? And apparently you don't even have sockets, which is like a little rough. With the component model, it means that, hey, actually now, if there's some library that's written in Python or some library that's written in Go, I can compile those libraries to components and compose them with stuff written from my own language. So for a person like myself, it's also particularly exciting because it means, oh, hey, now all of a sudden we're useful, right? And people might actually want to try it because they can actually depend on some packages that we might not have yet, right? And so when you start thinking about this kind of future where you have this cross ecosystem linking, it's actually pretty powerful. Yeah, like saying, oh, I want to use some machine learning libraries from Python, but also I want to use the cryptography stack from Go because it's super good, right? So it's a pretty exciting future that we think is being built, and you too can get involved in standards work. It's not necessarily just all low level stuff. The W3 C stuff is mostly around, yeah, some of the low level stuff, but work on WASI is mostly about enabling developers to do more, to have sockets and things like that. And with some more help, we can definitely move things along even faster. So feel free to get involved.
Actually, I chatted with Dave Bacher today, who is the champion of WASI sockets. And he really is just some guy. That's not his full-time job. He just does that he just did it for fun. He was like, I realized that the community had this gap. I kind of like low-level systems. He's a Kubernetes platform engineer, doesn't do WebAssembly for his day job at all. He just kind of had a side interest in it and just did it. And that's what's so amazing about WASI is that we now have this IDL, WIT. So you are able to define things with high-level types. And what you need to do is go look at what our current standards are, create a representation that will enable you to run it really well, wherever that kind of like standard thing is. Let's say I really want a WASI web GPU proposal room. Somebody make it for me, right? Is kind of what I'm asking for. And that's totally possible because that spec is well defined. I need a WIT definition of it, and I need a reference implementation in 2 different runtimes, and now it can move through the W3C phase process. Anybody can participate in that, and I would really love it if you do. A standard is kind of worthless if you don't have multiple organizations, multiple implementations, and a community that's driving it forward that makes it an open standard. You don't want just one company pushing it forward. So what we have right now is really our version of the OCI moment. That's what components are. It's write once, run anywhere, but for real this time. And I would also say that it is a new unit of distribute. So it's kind of like we just also defined a pod spec, but a pod spec that lets me compose all these different types of applications from entirely different ecosystems so that I'm completely breaking down all the language barriers, all these silos that we've artificially created over decades because we invest in one language and that language makes me pick one framework. And inside that one framework, I can only pick this one piece of middleware that works. And now I can't go and work with the Java team that's at my exact same company because we've been completely siloed. And so now, starting like this Thursday, we can have front-end engineers and back-end engineers and anybody working in any other ecosystem collaborating and building applications together in an extremely efficient way.
All right, excellent. Next up, I have common challenges to adoption, but I want to give the room an opportunity to process the conversation and pose some questions, if there's any right now. Scott?
I have a question. Oh, did someone else want to? You can do it first.
We are an OpenShift shop.
Yep.
Red Hat trying to contact the Red Hat to get the shim included. So
I gave a talk of this in OpenShift Commons. It's there now.
414. 414 is tech preview.
Yes.
415, 416, that is early next week. So when community thinking through for every run.
Repeat the question for the recording.
The question was about having access for the Kubernetes shim for the various runtimes for WebAssembly to be available not just on SPID on 414, but on all of the runtimes in a GA version of OpenShift.
Yeah, so the Run WASI project is a project from Deus Labs, also contributed to CNCF. I figure we should explain it, right?
Yes.
Okay. Yeah, so it uses the containerd shim. So what that basically means is the way that containerd runs is that it then also like can call into run C, and there's this shim layer that lets you kind of say which runtime you want it to run. And so you can pass in any different runtime and it will execute. That's really great for serverless workloads. It isn't really a great approximation for other types of workloads. But wonderful for that use case. I would say that it requires you to do some things that maybe some people would have questions about in their cluster. So like, if you're a platform engineer, platform operator, you need to make sure that you're cool with using a custom kubelet. You want to use different node pools for the workload, but you can overload it, right? You can have the same node pool serve different types of workloads, so you could mitigate that. Yeah, but I think the kubelet part is probably what most people are going to ask because that usually means that you're going to have some downtime. If you need to update the shim, then you need to take down your server and then update it. So what would work for you today on exactly the version of OpenShift that you're running is run a controller. Now, there's a bunch of different Kubernetes controller options that work well for WebAssembly workloads. We have one in CNCF Wasm Club So obviously I'm going to tell you to use that one. Cosmonic, full disclosure, is a managed Wasm cloud. So that's what we do. But CNCF Wasm Cloud had a contribution from Iceberg. I don't know him. He lives somewhere else, but he's been writing that controller and using that in production for himself. So I like that one. And then Cosmonic, also by Dan, who wrote it, and Jonas here. They created a controller that also does a deploy for you. So both of those are really good options. I know there's a few others. Wasm. No, it needs a custom node pool. Yeah, ours is Quasm.
That's great background. But yeah, I mean, for within the shim itself, given like all the caveats you gave, and like you're interested in doing this in a serverless way, like that's why we built this, to go see if people are really interested in this. And I'd be very interested to hear more about your use case and like what that would do for you, because one of the things we kind of wanted to put that out there in October, I think, in Chicago, was to say like, hey, we've got this, it works. Let's see if people actually want to use it. And then that makes sense, as we've been collaborating with Red Hat, and we ended up hiring this company, Liquid Reply, that did a lot of the work for that I helped manage. Like, let's see if there's people that like have a use case that's good for this. And if we can find establish that, then it makes sense for us, Red Hat, to go invest more energy into it. So I'd love to hear more afterwards.
All right, Scott.
How are we on time? I was mostly gonna get the most controversial kind of
It's 7.
stir thing.
We're good.
Okay. Then Oscar, would you say, and actually anyone, like this 3-year plan that you're talking about, and this kind of this idea that for composability within the same process using different languages, would you say it's the death of SDKs? I'm not trying to put words in your mouth. I guess I am.
We could just quote Luke. So Luke Wagner, one of the creators of WebAssembly, one of the main guys behind designing the component model, he calls this SDKs for free, which I think is a lot nicer way of saying the death of SDKs.
It is nice. Right.
Oh God.
But in reality,
yeah,
we're working on getting the WASI.2 APIs to all the standard language libraries. So in a way, your STL is basically an SDK, so they can't possibly be gone in that regard.
Yeah, I don't think they're not gone. They're still with you in spirit. But like the huge thing though is that it's like, hey, because if you here have ever written an SDK and then had to go do it in another language and then had to go do it in another language, it sucks. It's not fun. Sounds fun, or maybe it doesn't, but it's not actually fun. So being able to just generate them for every single language that is supported is actually pretty dang sweet. Now, if you want to get controversial about it, you can, start asking questions like, "Oh, well, but is it going to be idiomatic in all those languages?" And that's a different question.
We're working on that.
Yeah, we're working on that. Right now, questionable.
So that's the standard.
No, Wit's definitely super powerful for doing all this, and I think that's where like the open API as an opportunity to like tie those two together has a huge opportunity. That's definitely where I'm getting out of my technical depth as a guy. I did write an SDK for NPM for like in Go because I needed that for Vault. But like other than that, I'm mostly a sysadmin guy. So these are the smarter people in that one.
Most of the people that have come to me and were excited about the component model was literally this feature. Like this was what they cared about. A Red Panda engineer who gave a talk at Wasm Day, he was like, yeah, I just need to do the component model because there's no freaking way I'm going to write a JavaScript SDK. And I'm like, fair, I don't want to write JavaScript either. And so that's one of his key reasons is that they want to enable. I mean, think about it this way. If I'm writing my own code and I want other people to use it, I'm not just some guy that's written a whole language, but like I've written CLIs and I've written libraries that I want people to use. It sucks that we create a thing and then like only this tiny segment of people can use it. And they're gonna like just show you to the door because it's not Go native or this wasn't Rust. Like those are the communities that I see that are, Python people, they don't care. They'll run whatever. But I really am excited about that part of the feature. I think that that's gonna get people in the door. But all the other stuff is what's gonna keep them.
Python people run anything because they're like me, they're former sysadmins, and they're willing to just be like, hey, let's just change this and see what happens.
I think it's like they've seen things and they're like it's all awful, so
Any more questions before?
Going very low level. So to get cross language compatibility, do the compilers have to have a common mapping of structures internally?
Oh, they sure do.
So the new one requires a whole new set, and the old compilers won't work anymore. Or cross platform.
Well, so it's working in stages. So what we have is called the canonical ABI, which is a definition of what every single structure looks like from the high level types. So right now we have a bunch of tooling with WIT. So the main one's called WIT bindgen, for example. And so WIT bindgen will generate all of the low level code necessary that you don't need to have baked into the compilers. You can just tell your compiler, compile this code, and it'll work. Slowly, tool chains are starting to bring them into the compiler so you can do it natively, because that's going to be the holy grail, because ideally you don't have to run a secondary tool. So it's going to take a little bit of time for that to happen, but you can absolutely do this now without needing to change your compiler.
So the proposition is that if you want to build something, you first build an ABI, compile it into, transform it into your language, implement it in your language, so that other people can use it.
Yeah, so
you implement something and generate an ABI.
Right. So I think another way to look at it too is because we have WIT. What you can start by just saying actually. So it's WebAssembly interface types. And so it's basically, in fact, if you got one of the handouts, so shout out to Cosmonic. It's the WIT cheat sheet, or what does WIT look like? This is what it looks like. Maybe I can hold it up for the camera.
Yeah, we will include in the video notes, and I can send an email out with a link to the.
I actually have a component model book that's pretty awesome on the Bytecode Alliance. That's where I would point for reference documentation for a lot of this stuff. But yeah, we're very excited about WIT because before with WebAssembly, it's just, I call it a bunch of numbers in a trench coat, is how I describe a WebAssembly module versus a WebAssembly component where I can actually talk about things like strings. Like, we were just chatting about this, and I was like, dude, no, my favorite feature of the component model is strings. There's other stuff that's fine, whatever, but no, like the fact that I can pass in high level types and define my entire API that way, and then use a tool like WIT bindgen to generate language bindings that are sometimes idiomatic to the language that I'm generating it for, that's really awesome and powerful.
Yeah, so if you start by writing out your WIT file, like the actual interface for whatever library or thing that you're trying to build, you start there. You can have WIT bindgen generate the code that just says, "Hey, you got to implement this interface," or "You got to implement."
Over the years, I've written so many web services, and I'm like, now I have to handwrite the Open API because it doesn't translate that.
Well, so it does pretty well.
Because I didn't start with the Open API.
Oh,
You know.
I mean, there's lots of tools for generating your Open API, and WIT itself has a design goal of being machine generatable. So it wouldn't be that crazy if you used an existing tool to get your Open API, and then used a tool that takes Open API into WIT, and then WIT. So now you're, I'm gonna stop on that thought. But I mean, it's possible.
Yeah, and it's going to depend on your language too. So if you have, a strongly typed language, for example, it might be able to just say, "Oh, actually, I know exactly what the WIT definition for this module looks like," and it can just dump it out, and then you don't have to worry about it, right? Like that's totally something that's possible. And for languages that a lot of people are using these days, like Rust and things like that, they do have the types there. Python, Godspeed, but Python has some
It's getting
types.
better with annotations. Joel's done a ton of stuff on that. Shout out for Fermyon there.
Shout out. But yeah, it's totally possible from a lot of languages as long as the tool chains actually implement it. And a lot of them will. You should expect, especially like the super popular ones. Obviously, Rust is going to be the first one that's going to say, "Hey, here you go, ready to go, not a problem," right?
But you said something about my compiler has to do these things. LLVM already supports Wasm as a target, so a ton of different languages already have it. And when you look at the top 20 languages, basically 17 out of the top 20 have some level of support. And once you can,
always say new versions of the compilers would have to be written to support that, so they would have a common.
What would make me happiest is if they targeted the canonical ABI directly, but we can actually trick them with this adapter tool. So we've supported WebAssembly modules since LLVM supported since 2017-ish, really before, because on the front end with Wasm.js, that's a long story. Let's pretend it's 2017. And 2019 is when it became the official fourth language of the web. That's like, boom, standard, it's got everything, we love it. But 2017, people were shipping it in production everywhere, like Adobe and Autodesk and a ton of other people. Me, that's ass. But anyways, it targets a Wasm module. We're talking about WebAssembly components. It is a different binary format, but really it's like it wraps a WebAssembly module with some metadata about the high-level types. So long as you have a .wasm created since 2017, I can take that with another .wasm that knows how to adapt that into my new .wasm that is super and awesome. And so my platform is just like, look, I don't care if it's a module, it's going to be a component once it comes in. And that lets you take those existing, based on the core WebAssembly specification, lets me have a component that I can now compose with any language. It's crazy cool. Like, can you imagine backwards compatibility to 2017 when you hadn't even designed this language yet? It's cool. Props to Luke on that one. I didn't do that.
Yeah, that was like
Cool. Questions? All right. So, I guess next, what are some common challenges that you see to adoption around this? I know Wasm Cloud, CMCF project, Sandbox. Fermyon has a platform. How does F5 factor into all this? If you all can speak a little bit to positioning, value proposition, challenges that you're seeing in the field, that'd be great.
So I mean, with any new technology, right? There's going to be. I typically do a lot of startups. One of the things I like to say is startups is like, you go into the meeting and people are like, "I want 10 things," and I'm like, "Cool, I do 2." With some like really crappy glue code, maybe I'll do like half of the third one, but I ain't supporting that. And it's better than nothing, so you're gonna be happy with it. And I think there's a lot with where we're at as an ecosystem today of like, this is gonna like WebAssembly is gonna eat the world. It's gonna change lots of things, right? And I think it's gonna change the way people build applications for sure. It's not taking over all of that tomorrow because there's lots of things that we need to be doing, right? Like all the work that's been happening on the standards, like you mentioned WASI Cloud, right? Which is like, let's go implement all of the sort of interfaces you would want to have. And there's 2 ways of like thinking about this, right? There's like the way that we've done this historically is you go write a library that opens a socket that calls out to the thing, right? And or calls out to whatever that is. And so like sockets with some evolution over time will hopefully get there where we can use a lot of that existing code. And I think that'll be a huge piece. But the way people want to build stuff in the future, WASI Cloud's the right way to build in the future. Because I should be able to say, like, I need a KV, I need a relational database, I need a neural network, I need all of these things, right? And then as a developer, I should write to these specs, and then operations in the backend implements those. If I want to move this to a different cloud somewhere else, like we implement those pieces in the future. Like a lot of stuff just doesn't exist yet. Like some of it's there, but some of it doesn't exist. Some of it's in a nascent place. So like it's gonna take time to go build that. And the more that you have to go build new stuff as the person implementing it yourself, right? The less brownfield stuff can just move, right? And so like the ideal world would be like, and this is one of the great things about I think Kubernetes is be like, okay, once like I could take my app and containerize it, and now I can just shove it somewhere. And we saw lots of really terrible like multi-gigabyte containers that people shoved somewhere with way too much stuff in them, but technically it worked, right? And like it's that brownfield migration stuff that like I think we need to get as we get better about that, we're going to start seeing more and more of a tidal wave of things come over. But like really the promise is in the greenfield. And the thing is people out there are only writing so much code every year. And so the greenfield will take longer to grow and take advantage of all of these things. And to be frank, as I said, not all those things are there, so that's got to grow as well. Like I think this is all just takes time and it's building on itself as it comes in and the brownfield becomes easier and more of this we're taking advantage of more of these more mature features. We're going to see more and more of this adoption.
I think it's really critical that we expand in the standard language libraries first for a lot of these things. Right now we have WASI HTTP, so you can make HTTP requests, but there's some friction there because we designed it so that it's a low-level API that any library on top could do whatever they normally do for manipulating headers and body and streams and all those aspects. And so That's not what I want. What I want is to call fetch when I'm writing in JavaScript. I don't want to write in JavaScript. When I'm writing in Go, I want to call netHTTP, and I want to use the HTTP client library. And so we have the AP, WASI's was a major step, right? We have a standard, so now the STLs are willing to implement it and adopt those standards. That's the first step that we had to cross that barrier, and they're willing to do it because you've got the W3C stamp of approval behind it. You've got reference implementations, but that is not enough, right? Like that's the first thing you need. You need ecosystem. You need more high-level APIs that let us have all these other complications of writing non-functional requirements fade away from the code that you write, so that you're writing a component that only has your business logic in it. I don't want a bunch of clients inside my same component, right? Because whenever I have a CVE or any other issue, it's always those. It's always the clients that are the problem. It's never my business logic. And so I want that piece to be the thing that people focus on. And I think once they realize they get SDKs for free, that they get this sandboxing technology that actually keeps you safe, containers don't keep you safe, and then you're able to write components that let you work with anybody in the world. I think that is how we end up eating the world. But we're definitely early days because of where the standards were.
Yeah, I think so much of it really is tooling and making it accessible for the everyday developer to actually use it. Because I think we all sit in this room and we're up here preaching the great word of WebAssembly, but then a lot of you are going to go home and then you're going to try it and you're going to be like, this doesn't sound like what they were talking about. Right. But the thing is you have folks in the community. You have folks like Fermyon, which I would argue Fermyon Spin, they have a project called Spin, is probably the fastest way for you as a human being to write an application in WebAssembly and have it up and running. Like you can write your first app in less than a minute. And like I think that's phenomenal, like the work that they've done, right? And then you look at people like Cosmonic, which is oh, actually, what if I want a WebAssembly app and I want it just hyper networked? Like I want it to just work. I want it to run on my watch and like actually talk to something else. I can do that with Cosmonic with Wasm Cloud, right? So we need more people who are actually working in this area to bring it to people to say, hey, actually, we want to build with this stuff, right? And especially even at F5, as I'm going around saying, hey, we got to use WebAssembly for absolutely everything. That's the biggest thing is like, okay, how easy is it for our developers to actually use? And I'm like, well, you can just DM me on Slack. I'm good for it, right? But we have to get a little bit further than we are today. But that's a lot of the work that's happening with the component model is exactly this. Like if you go start snooping around the WebAssembly org on GitHub and looking at the tooling around the component model, you take a look at JCO. Maybe you hate JavaScript, but and I don't know if that'll make you like it more, but the things you can do with JCO and actually starting to work with components and put pieces together, it's truly phenomenal. And so as this tooling matures, we're going to be in a beautiful place. And then you can go to your boss and say, hey, I built this thing and it took me, an hour. Maybe we can roll this out to the rest of the team. And that's how stuff will start coming together.
And as a platform engineering team, I imagine that's a common persona in the room. You're probably often thinking about what are the golden paths that my users are on, right? And that's what I think makes components really shine is you're probably going to be part of the team that's deciding what my authentication story is, what my authorization story is. What are all those common middleware pieces and common services that everybody has to deploy? Those things that maybe you've instituted some type of required monthly update that turns into some human build network where we rebuild all our crap, and that's really painful. Like, what if you got rid of that? And then you only had to rebuild your code when it actually changed. Everything else is actually composed together, relinked, and you can do that at runtime. So there's like so much promise, but there's a lot of work to be done. I want everybody in the room to join the Bytecode Alliance, please. Yeah, awesome foundation. We build Wasm Time, Fermyon, Cosmonic /CNCF Wasm Cloud. We use Wasm Time as our WebAssembly runtime. It's obviously my favorite, but hey, all the browsers have it too. There's also Whammer inside the Bytecode Alliance, and that's perfect for running in tiny places like your watch or your dishwasher. They literally have a dishwasher talk. I'm not even joking. So Between that, you've got WitBindgen, which needs a lot. We need a lot more languages to join that part. And let's see, one more. Wasm tools. That's actually a really cool project. There's a lot of performance optimization that we need to do there. So that's another key part that you can add and contribute. And then also, sorry, one more thing. If you use middleware and you're interested in the component model, it would be really great if you, in your favorite middleware library, added .2 as one of your targets, because that's how we're going to grow the ecosystem.
I want to give one more example. Another way that moves WebAssembly forward is other people just doing it first, because then you can copy them. So something that a lot of people wanted to do inside of the WebAssembly community was, I want to run JavaScript inside of WebAssembly. We can get into that later on why anyone would want to do that. I swear it's a good idea. But the point is that's scary. Who's going to compile a full JavaScript runtime to WebAssembly so we can run some JavaScript? Well, Shopify was like, honestly, like we want to do that, and so they put out a project called it's pronounced JV, but I'm gonna call it Javi. And it's a project that is, hey, here is a JavaScript, please give me a WebAssembly module that will execute this JavaScript code. And then pretty much everyone else was like, that is fire. And then and now
One of those.
everyone runs like that. Like that's one of the major ways. Like not everyone use anymore. Some people are like, because JV uses QuickJS, which is a JavaScript runtime. A lot of people now are like, we want Spider Monkey, which is, that's cool too. But it's like now everybody is running JavaScript in WebAssembly, and it's mostly because Shopify was like, honestly, we need to do this. Like it's good for our platform, right? So just don't be afraid to go off and do something because it sounds crazy. Just go do it and publish it, and people will run it in production. So
Same as it ever was.
Typing interpreter, WebAssembly.
Yeah, so yeah, with both like JavaScript, we use the QuickJS as a cheat sheet in Python. Similarly, we basically take the interpreter, we take your code, we bolt it together, we turn that into WebAssembly, and then we use one of those the cool tools are built for WebAssembly called Wiser to pre-initialize. So every WebAssembly we do, we pre-initialize it to the point where it would take the first instruction. So if you run Python locally, run like Python, like my main.py, like it loads the interpreter, loads your code, it takes a second and it runs. It'll be faster running spin to do that because the WebAssembly is already like pre-initialized that. But it's not like quite the same because it's an interpreted language. It's not the same as like when you compile C or Rust to that intermediary. Like the intermediary that we're doing is basically creating something that like the intermediary is like your code bolted to this interpreter compiled into that intermediary.
Yeah, that original project started actually at Single Store. Kevin Smith, giving him a shout out. He's the one that did the crazy idea with C Python, and then he started working with Brett Cannon, who's a Python maintainer, and then later on Joel Dice, who I gave a shout out before, because the things that he did to make it work with the component model is amazing. Being able to run other like the Python ecosystem, I've been picking on it really hard because it deserves it, but. Yeah. It has stuff in it like Fortran and like other things that you would never expect. It's the problem is not getting Python to work, right? Python easy, everything else hard. And so he had built out a lot of the tooling inside Componentized Py, and that's inside the Bytecode Alliance project. Getting the C Python interpreter compiled into WebAssembly was an interesting project, but I think that only took like 1 to 2 months. And then from there, it was about like, okay, well, we need sockets. That was one thing that like opened up the rest of being able to compile things without us coming stuff out. But that was a pretty big enhancement. And now what that's driving, because of how much of a Frankenstein language it is, that pattern actually we're able to apply to other different languages that are coming online that have exactly the same use case. C Ruby, exact same thing. So all these same patterns we're going to be able to stamp out and roll out more languages faster with all the same shared tooling. Like a lot of this stuff we've been pushing into Wasm tools. That's the other project. I was like, I need more contributors to Wasm tools. So like shout out to that because everything is going through that. Anyways, those are cool things.
Other questions?
Yeah, I got a quick question. Well, I have two of them for you. One is, um, so the answer earlier about typing and how that will be able to help with mapping. When you're actually, I know Fermyon folks, but I've never actually asked this. Uh do you prefer to use TypeScript, for example, for that reason when you're doing something with JavaScript? And are there other, and for anyone else too, are there other, is that a general pattern for the languages that you choose? It may not be if they're not already strongly typed at their core.
I haven't used TypeScript. Almost 2 years. A company called Prisma, which is a strongly typed ORM for TypeScript. So I spent way too much time writing way too much TypeScript and putting lots of any's in there because, again, I'm a sysadmin.
It's called TypeScript, not any script.
Just go look at my GitHub if you want to like have a headache. I think your point really is going into like what Wit can do with that, and frankly, like that's where it just passed beyond me of like, let me go message Till, who is one of the original creators of WebAssembly and happens to work with us and is like an amazing JavaScript guru. But yeah, I don't have a great answer. You guys probably have a better answer for why the type would matter for Wit and how you translate that.
Honestly, I don't think it really matters what language you use. The most important thing is just that you have that interface. That's the only part that matters, right? Leave it up to some compiler nerd to figure out how to make it all work, right? But beyond that, like even if you're using Python without annotations, right? It's mostly like, hey, what's going to generate maybe an interface for you that you have to implement. Hopefully, maybe there are a couple type annotations that say, hey, these should be your types. But so long as you actually pass the values that you said, then everything should be okay. Of course, typing is great in general, but it's not perfectly necessary. And I think that was an important design goal for the component model was it should be able to work with any language. Your language, need not be the most strongly typed thing in the world. Because remember, again, one of the biggest goals was this thing has to work with JavaScript, right? And JavaScript is not going. JavaScript's not going to do types for itself. It's not going to do types for you, right? So I think that
Gotcha.
it'll be fine.
Yeah. So if I'm hearing this right, is this a good summary that strong typing or some other layer on top of your dynamically typed language like TypeScript or something like that would be helpful because you get your mapping for free pretty much, or you get that mapping, but Wit's goal was to have that not as a requirement, and all you need to do is to do that required thing, which is to do that mapping. As long as you follow your own rules, you should be good.
It's just so they can talk to each other,
Yeah.
like cross
Yeah.
language. That's it. So it's mostly like if Python says, "Hey, this thing's a string," and you have some JavaScript code that's like, "Oh, this thing is a string," and by the way, they have two completely different representations, right? The important thing was that they know what each other's talking about and they're able to communicate effectively.
That makes sense. And also, is anyone here from Philly?
Really? No? What feeling, Jimmy?
Is this? Do you know that I'm going to ask the cheesesteak question?
No.
So if you order cheesesteak, this is just a tiny anecdote. Wit is one component for ordering a cheesesteak. Wit and wit out.
Nope.
Anyway, it just means fried onions or not.
We're the New York meetup.
Wait.
Exists.
It's just
But I'm sure RCS was really trying to push how when so at some point like super important will be able to have like some kind of component repositories and pull it off the shelf. There's also like potentially have like a WIT compository. It's like what kind of acronym could I come up with so it's WIT beer is a repository.
Yes.
Yes. Cool. Other questions? All right. I have one more. One of the things that in learning about this, which I'm still new to, that really resonated was the hopefully helps promote adoption is the reduce environmental impact by adopting these technologies because of things like density. Can you all speak a little bit to that?
Fermion, take it away.
So literally has been spending all of our messaging lately really trying to hammer density in. and that's the direction that we're going, is to make that the clearest point. And there's two aspects to that, right? There's like it saves you money, and then there's like you're using less resources, so like there's a huge environmental impact. So like the Butcher, our CEO, when he was at Microsoft after the acquisition of Deus Labs, he was touring one of the Azure data centers. He was talking to the guy who runs the data center, and Butcher's like, "Hey, what's your biggest problem?" The guy's like, "I can't build like see all these servers, see these data centers. I can't build them fast enough, right? See all these blinky lights. These things are 20% utilized because of how poorly people build stuff in the cloud and how poorly people like do things because of the way that you have to be for scale to just be like, well, I can't just sit there and like provision just exactly what I need because that changes. So I'm going to provision in more, and every single layer is going to provision in more. And so therefore, you're not using the resources. We could have way fewer data centers than we have today doing the same amount or more work if we actually use those resources effectively. And a big, like, that was a lot of the impetus of Fermyon as a company was he was like, how can we improve solve the situation? And so with Microsoft in that the Deus Labs group, they were pushed to be like, let's make the Kubernetes ecosystem better. And Matt Butcher, we always call him Butcher, is our founder. He was one of the creators of Helm, so very familiar with Kubernetes. But he's like, at some point we gotta maybe this Kubernetes thing isn't necessarily the right only way to do this. Like, let's look at serverless, and then we're like, God, Azure Functions is terrible. Like the way they do this is so highly inefficient. It's not making this any better, right? We have massive cold start times because of what we have to do, and we have all of these different platform requirements. We have to go mix and match and move stuff around. It's really difficult. So, like, is there a better, faster way to do that? And this is where they stumbled across WebAssembly. And again, as we talked about, like right off the bat, like as Oscar Baylor would go right out there was like, it's super, super small and it's super, super secure. You can run it anywhere on things that people like all know are cheaper and more efficient, like ARM, but don't tend to write their stuff to because they just write it on x86, right? Like we have all of these great things that occur to that can drive to this density story. And that's where like, our impetus now has been, so we built our company, Fermyon, it's a physics thing, Fermi. We're a tech company, so I have to spell it weird with a Y. It's a requirement. And then all of our things are named after physics puns. So our internal thing that's really, really dense, of which we've tested running tens of thousands of applications at once, is called LHC for Large Hadron Collider. Um, we're building now, so we've got this Run WASI shim implementation. We're continuing to iterate on the Kubernetes ecosystem. Like, how can we bring all this efficiency back to Kubernetes, which has what you mentioned here of like, well, it's going to inject the current runtime because that's not going to work for us. But we can use the scheduling in order to drive the density, right? And it's that density that we're going to be able to achieve because things are so small, because they can start up so fast that like we can have a request come in and they're like, boom, I've got 10,000 requests. Let's just spin off a bunch of threads. I can do that way quicker than I'd be able to go deploy more pods or do anything else and use that hardware to a greater degree. I think that's a critical story, and that's one of the biggest things we're going to see. And it's going to be, I think, not just the dollars, but as you mentioned, it's going to be a lot about the environmental impact of them not building another data center, using the resources we have even more effectively.
And one point that I want to hammer home that he didn't mention explicitly is that WebAssembly gives you the ability to scale to zero. So when you are not computing, you do not have to use any resources. Because the modules are so small and because they can be initialized so quickly, if a request comes in, you could have the module not even in memory. You could say, oh, the request is coming in. Let me load this module off disk. Let me boot it up and let me respond to the request. And then I can shut it down. So if you are, maybe it's overnight and you're barely getting any traffic, you don't have to pay for a thing. Or in the middle of the day, it's the Super Bowl or something. You can spin up to these millions and millions, and only for that moment, and you can immediately spin back down. And so the environmental impact of that is actually tremendous, and it's something that we have to think about quite a bit. One other point I wanted to make was also just accessibility, right? Because WebAssembly is portable and can run anywhere, let's say you have a module running on your user's device and you detect, hey, their device actually isn't that fast. They're not getting the same experience as the other users. If you wanted, you could take that same exact module and run it on your server side. You could move that computation to the server side and start streaming back the data to that device so that way they get a better experience because you have a faster server. These are things that are enabled by WebAssembly that we haven't even considered because it hasn't been a true option for us yet. So it's something, even, we're excited about it for all the other things, but even just from like a societal impact and from, it's just the world ecosystem impact is actually pretty huge. And there's way more work we can do there that we're not even thinking about.
Yeah, if you're interested in that, Adobe published a CNCF blog post on reducing total cost of ownership. It's the inversion of that use case where they had everything running server side, and they used they had it instead run in the browser so that they didn't have to pay the ingress cost, which is kind of cool. I thought.
You can also save a ton of money. Yeah.
The FinUp story.
See, reduction in TCO. There might be a sustainability story there, but real talk, the first time I ever heard about it was from Kate Goldenring, who's at Fermyon, and she gave a talk at Wasm Day over a year ago, and then I was like, oh my god, I'm so excited about that because that makes me feel like I'm working on something that really matters, and that's basically what she said in the talk. So I just totally ripped that, but we gave a talk together, and it was really important to her that we didn't just kind of like do some kind of greenwashing, that we really technically walked through all the different ways and reasons why it makes a huge difference. So if you're interested in that, look for that Wasm Day talk that we did together. It talks through just about the component model. It's one of the earlier component model talks, so it's a good one for an intro.
It was a good.
Share that out. All right. Anything else? Tony.
For someone that's maybe comfortable in one of the popular JavaScript or Python, and they want to learn about WebAssembly, like what are the learning resources that someone can use? It's not a super genius, maybe a person of average intelligence, maybe sitting in this chair right now, is now curious. You pique their curiosity, they see the benefits, right? So are there, the books that you recommend, or they're like, is the documentation really well done? Like how would you?
Read the codes, right?
So the documentation was not helpful to me. That's why I'm asking.
I'm curious. Are you trying to learn this as, like to use Kubernetes as a corollary? Are you trying to learn like I like to learn how to use Kubernetes, or I would like to learn how to re-implement Containerd?
So the most interesting part is that we're all comfortable with different things, right? But I like the idea of I already went 90%, created something useful. I can turn it into like a reusable component, right? So it's that's the part that I'm curious about, specifically about learning, right? Like writing something in JavaScript or Python. They've got strong opinions about Python, right?
All of them,
Right.
really.
So writing
We can
something,
bash Python.
and then how do I turn this into a component? How do I learn how to use other WebAssembly components? Are there any learning resources?
Yeah, there's the Linux Foundation has training. I bailed out of it, so I can't tell you if it's too good or not. There's a component model book in the Bytecode Alliance that we're investing a lot of our time and effort in making better. Shout out to Kate for that too, and Ivan. We also I would say if I'm trying to learn, what I would do is get my hands dirty. I would take the thing that I've already made, which is always a to-do app, and I would try to make it work with the existing tool chains, which is JCO, that's inside the Bytecode Alliance, and Componentized Pi inside the Bytecode Alliance. And then once I had that component, I would run it with Wasm time served. So Wasm time is one of the most popular runtimes that's used by basically anybody that's doing server-side Wasm. And there's this command called serve. So if you give it an HTTP API, which is pretty easy, and then you would add a, hello, I got here, right? You can get that by curling after you run Wasm time serve. I think that's like the bare bones way of getting in there and working directly with the tool chains, directly with the pieces that have that the WASI shims in them, effectively. And then you can go and check out these other application platforms that have SDKs that make it a lot easier. We have opinions about what pieces you might want and that kind of thing, but I think getting in there and the raw stuff is probably the best way to learn. Is there documentation? Man, I wish there was. It's a great contribution opportunity.
Huge contribution opportunity.
I mean, I think I would take the opposite approach. If you want to get time to value faster and then decide if you want to go deep, like go with a Cosmonic or with Spin and like get where like we both have like getting started. So you go do the cool thing right away and then get your code to work. We have that in a more prescriptive way, then we build it into that. And then like there's a lot of like we're using Wasm time under the hood, and you can go get some of these things to run on Wasm time if you want to go do that with Wasm time serve. Like I think that's an extra layer of things you need to understand that you can probably get your time to value much quicker by using one of these higher level tools, right? And then take it down a level after that.
At the end of the day, WebAssembly is a compiler target. It's like just replace WebAssembly with x86 or ARM or whatever, and like you would never be like, oh man, what do these instructions do? Like I don't know, right? So it's like it's exactly that. It's just go build a thing, and then your curiosity will be piqued, and then you'll start to go dig deeper, and you'll find everything you need to. And if you can't find the docs, join the Bytecode Alliance Zulip. You can ask questions. People know things.
Work together. We need to jump on Teams.
Yeah.
Do not ever message me on Microsoft Teams. And I know you're on Teams because I messaged you on Slack and you didn't respond. So I was like, I bet he's on Teams. So
We got both.
yeah. But yeah, it's exactly that. It's that the people in the community are all super duper friendly and they're more than excited to talk to you. Like so don't feel afraid to ask questions. People are ready and willing. They want you to get involved. They want you to understand. They want you to contribute. So don't feel afraid. It's still the early days, but that's okay. We're all learning together.
And is that the same answer? That's the only reason I'm piggybacking now. Is that the same answer to the question that with Bailey when you were saying like, hey, you know, a great contribution would be to take what you're developing and make it componentized, right? Like, is it the same answer to the question, if I want to do that, how do I know if my application is like, how do I know if my application's ready for that? Or how do I know what, basically, is that right for me? Or what are the roadblocks between here and there? Is what you just said same answer? Like get on the mailing list?
Just do it.
Honestly,
I mean, yeah, you can try to compile and it'll tell you.
oh, it'll tell you real quick. So you'll know whether or not, like, especially like if it's a C app or something like that. Like you have an old C app and you're just saying, I want to compile this to WebAssembly. Just try. Because you'll get compiler errors, or even if you have an existing Rust project, and you're like, I want to compile this to WebAssembly. Just change that target and just see what happens, right? And you'll be shocked a lot more of the time than you expect it'll work. Because it turns out, I mean, we all use tons of system calls, but like if you're not using a ton of system calls in your programs, they probably will just work. If they're the common ones, they'll just work. If it's sockets, come talk to us later. You know. But yeah,
Thursday.
talk to us on Thursday.
If you're using cryptography, talk to me too. There's a lot of stuff that maybe you need hardware accelerated APIs. And then literally talk to me in that, like, I would love for us to have a WASI proposal for that and move that forward. But I really, if you're doing Rust, C, C++, anything that uses the LLVM compiler, like just try it and it'll tell you exactly what's wrong. You might get into the situation where maybe you have some dependencies that are doing some weird syscall things, and hey, you're compiling to a sandbox. You wanted that. There's some caveats for how you get to that.
And are the results of those talks that you're saying, talk to us, right? Is there a home for the results of that? Like, so for example, like whether that's just a matrix of, yes, these things are supported. If you want to do this, like here are the caveats, and then here's a roadmap because like we're not even close. Like, is there kind of a home for those things so that those conversations don't have to happen over and over?
So there's a lot happening inside the Bytecode Alliance space. A lot of people go to the Zulip, and then I do my very best to direct them to GitHub issues inside the WebAssembly organization and GitHub. And we try to have a representation for that of like common things, so you should be able to find things there. The reason why I paused is that I don't like what we currently are doing, where we have lots of different proposals, and so those are different GitHub repositories, and that can be kind of hard to navigate. And unfortunately, I have like a mental Rolodex of all the places and all the things that have happened that I just try to work as like a controller and be like, oh, I'll plug you in here, and I know you should be talking to Luke or you should be talking to Oscar. vice versa. Now, there is a lot of activity in Zulip. There's also an awesome Discord too. We've been hyping the Zulip, but I hate Zulip. I think the Discord's better. And so there's just a WebAssembly Discord that's a really good place to hang out. And so it's so active.
You can also leak our DMs. That'll work too.
Started trying to build a matrix for spin in particular for that.
Okay.
There's so much more that needs to go into that. Like I'm again, as the solutions engineer background person, I'm like, let me start with all the things it won't do, and then we'll move on from there. So you don't be surprised later. Like you still want it, but just take these asks and put them on the shelf.
It's like when you're trying to get a dessert at a diner.
Yeah.
You know, you order one dessert and they're like, we don't have that. You say like 5 things and then we don't have that. Like, tell me what you don't have. Yeah. Thank you.
All right. With that, I am going to go ahead and call it so that we can, if you want to.